In this video, you guys are going to be converting repeating decimals into fractions. Now, I'm just going to give you this disclaimer. It's not the easiest thing, but there are very distinct steps. Each of the examples that I gave you, I repeated the same steps. I actually repeated the same slide, I just did a different problem. So it's in your best interest while you're watching this video to jot down the steps, because these steps, until you get familiar with converting repeating decimals into fractions, will really help you. Not all repeating decimals get converted by using the same denominator, but they do get converted using the same process. So it's really important that you follow the steps.
So we're going to turn 0.8 repeating into a fraction. So 0.8 is the only digit that repeats. So you're going to set x equal to, let's just do 0.8 repeating. Step 2, create an equivalent equation to the first where the repeating digits touch the decimal point on the left side. So right now the repeating digit is touching on the right side, and in order to move it over so that it touches on the left side, we moved it over one place. So like we said in the converting decimals to percents and percents to decimals video, when you move a decimal one place, you're basically multiplying by 10. So one place over to the right is multiplying by 10. So we're going to create an equation, 10x equals 8.8, repeating. And this equation and this equation are equivalent equations. Now step 3 says to create an equivalent equation where the repeating digits touch the decimal point on the right side. So if we go back to the original equation, it just happens that in this case, when a single number repeats following the decimal point, like 0.8 repeating or 0.3 repeating or 0.4 repeating, you're going to rewrite the original equation. And then you're going to subtract the two equations. So 10, and we remember there's a 1 in front of that x. So 10 minus 1 is 9x, and 8.8 repeating minus 0.8 repeating is going to give us 8. And then in order to solve for x, we're going to divide both sides by 9. And so we're going to end up with 8/9. What you should notice about this particular fraction, as well as any decimal that repeats right after the decimal point, you're going to end up with a fraction whose denominator is that many 9. So like 0.8, 8 repeats. It's going to be one number, 8 over 9. If it was 0.82 and the 82 repeated, it would be 82 over 99. However, there are decimals that are not going to repeat right after the decimal point. So this method will work for converting all repeating decimals into fractions. So now we're going to deal with the decimal 0.83 repeating. So in this case, the repeating digit does not immediately follow the decimal point. So I'm going to set the repeating decimal equal to x. So x is going to equal 0.83 repeating. Step 2 says to create an equivalent equation to the first where the repeating digits touches the decimal point on the left side. So right now what touches the decimal point on the left side is 0. We want the 3 to touch the decimal point on the left side because 3 is what repeats. So the number that would mean that the 3 touches the decimal point on the left side would be 83.3 repeating. Yeah, there's a 3 that touches on the right side as well, but that's always going to happen when your repeating digit ends up touching on the left side as well. So now we have to figure, in order to get from 0.83 repeating to 83.3 repeating, what did you multiply by? Well, you moved the decimal point over 2 spaces, so therefore you multiplied by 100. So the equivalent equation would be 100x equals 83.3 repeating. Step 3. Create an equivalent equation where the repeating digits touch the decimal point on the right side. Well, right now on the right side, what touches the decimal point is 8. So we don't want 8 to touch, we want 3 to touch. So the number that we would create in order for 3 to touch on the right side would be 8.3 repeating. Now the 3 touches on the right side. To get from your original equation down to 8.3 repeating, what did you have to multiply 0.83 by to get 8.3? repeating. Well, you have to multiply by 10 because you move the decimal point one place now over to the right. Subtract the two equivalent equations from each other and solve for x. So that means I'm going to subtract 100 minus 10 and I'm going to get 90x equals, and I'm going to have to do subtraction. Sometimes you're going to have to do side subtraction of 83 minus 83.3 repeating minus 8.3. And you're going to get 75. And then you're going to divide by 90 on both sides because that's how you get rid of the 90 in front of x. And then you're hopefully going to reduce it by dividing by 5. So you're going to get 15 over 18. Holy cow, you can go again. Divide by 3. And you get 5 over 6. So your final answer is 5 over 6. So 5 over 6 gives us 0.83 repeating. And I did this example on purpose because you actually, in your fraction decimal percent video, converted 5/6 into 0.83 repeating. So I'm going to convert 0.326 repeating into a fraction. In this case, this decimal has two digits that repeat, and they don't immediately follow the decimal point. I still follow the same rules. I'm going to go ahead and set the decimal equal to x. Then I'm going to create an equivalent equation to the first where the repeating digits touch the decimal point on the left side. So the number becomes 326.26 repeating. Here's my repeating digits, and it touches on the left side. In order to get from 0.326 to 326, I move the decimal point 3 spaces, which is the same as multiplying by 1,000. So therefore, I'm going to multiply the left side of the equation, or x, by 1,000. Now I'm going to create a third equivalent equation. I'm going to go back to the first equation, and I'm going to say I want the repeating decimals to touch the decimal point on the right side. Therefore, it's going to be 3.26 repeating. In order to get from 0.326 to 3.26, I move the decimal point this time only one place, and therefore it was 10x. Now I'm going to subtract the two equivalent equations from each other, so 1,000 minus 10 is 990 x, and 326.26 minus 3.26 equals 323. Now I'm going to divide both sides by 990, smushed in there at the bottom. And if I could reduce that, I would. In this case, because it's such a funky number, 323 over 990, I wouldn't really take points off in this situation. I don't want you spending 5 minutes trying to figure out the common factors of 323 and 990. If they both ended in 5, if they were even, okay, if it was an easily reducible fraction, then yeah, I may take points off. But in this case, 323 divided by 990, don't waste your time. Okay, it's 323, looks prime to me, so your final answer could be 323 divided by 990. Remember, you can always check to make sure by taking out your calculator and dividing 323 by 990.